So now that we've talked about the Java FutureTask, let's take a step back and evaluate its pros and cons. And we're going to evaluate its pros and cons in the context of our PrimeChecker app. So we'll also talk about the PrimeChecker app as well as talking about the FutureTask. So this version of the PrimeChecker app fixed the limitation with the previous version. And the previous version that we looked at depended on having access to concurrent hash map and the semantics that are available in Java 8 and beyond. So if you don't have that, then you're kind of stuck. So FutureTask will help us get the semantics we want without being beholden to modern versions of Java. Now, quite frankly, people need to get with the program and upgrade their systems to newer versions of Java, but there are some applications that take a long time. And if you work commercially, you'll often find out that there's reasons why people stick with older versions of stuff. But, honestly, when did Java 5 come out? That was something like 20 years ago. So it's probably time to argue for an upgrade. There is still a limitation, however, with this particular approach. If we use the memoizer for a long period of time on a wide range of inputs, it'll keep growing and growing and growing, and it'll never clean itself up. Now, that's probably not really a problem for some of the things that we're trying to do. But if you were really trying to use memoizers for other purposes where you might have phases or waves of computation that would run for a while and then never be accessed again, you might want to have some way to be able to clean up the memoizer, because there's no sense keeping around key value pairs that are never going to be accessed again. It kind of defeats the whole purpose of having a memoizer. So we're going to fix this particular limitation next time when we talk about the Java scheduled executor service, which is probably one of the major last things we have to cover with Java concurrency and the frameworks in the executor framework in this course. So let's also briefly evaluate Java FutureTask. So as you see, by using Java 8's compute if absent method, there is no more need to do this FutureTask-based implementation. And so this is what it looks like with the FutureTask-based version, which works, which is super cool, which is documented in the Java concurrency and practice book by Brian Getz and his colleagues. However, I think you'll agree with me that you'd much rather write this code than this code. This code is tricky and error prone and so on, but this code is super duper optimized and super duper concise. And of course, Doug Lee wrote the implementation of this, so it's going to be arguably more efficient than this implementation because he didn't use FutureTask. He used lower level mechanisms that are even more optimized. So if you can use Java 8, then you want to stick with this way of doing things. But if you can't, then now you know a way to be able to get the same semantics by using earlier versions of Java. Okay, so that's the end of our discussion of FutureTask. And what we'll do next time is start talking about the scheduled executor service framework, which builds time into executor service computations.